Now we're going to look at circles. Now I know this lesson is going to seem a lot like review of stuff you've already seen before. However, don't let it fool you. Chapter 10 does get pretty complex and complicated. Okay, so don't slack off on your homework just because, oh, it's circles, I know what a radius and a diameter is. Okay, so make sure you are doing your homework for this chapter. This is a chapter that people usually fall down on. Okay, so again, this first section is just kind of reviewing some vocabulary about circles. So, fix this here. A circle is a set of points equidistant from a given point. Okay, so you have a point in your circle, and it is the set of point equidistant. So those points around that given point. Okay, that's a circle. So that given point is called the center. Okay, so you have a center point. And the symbol for a circle is a circle. Okay, so that's your symbol for a circle. So I'm going to go over the different types of segments that you could have inside your circle. So the first one is a radius. Okay, plural is radii. That is a segment with endpoints at the center and on the circle. Okay, so on that circle above, the points around the outside here, that's your circle. Okay, so around the outside, that's your circle. Your center point is in the center. Okay, so your radius is the segment with endpoints at the center and then one on the circle. Okay, so that would be a radius. So that's one segment inside your circle. Another is called a chord. Okay, so a chord is a segment with endpoints on the circle. Okay, so I just need two endpoints on the circle to make a chord. Okay, it doesn't have to go through the center. Just two endpoints that are on the circle would be a chord. Okay, then we also have a diameter. That is a chord. Okay, so again, your endpoints are on the circle. That passes through the center of the circle. Okay, it is made up of collinear radii. Okay, so this chord has to go through the center of that circle with endpoints on the circle. So this would be a diameter. Okay, and it is made up of collinear radii. So you can see from the center on the circle, that's a radius. Center on the circle, that's a radius, and they form that straight line. Okay, so this is a diameter. Okay, so our different parts of a circle there. Now your radius is 1/2 of the diameter. Okay, so if you're given the diameter, you can divide it by 2 to find your radius. And then vice versa, your diameter is equal to 2 times the radius. So if you're given the radius, you can multiply it by 2. That will give you the diameter length. Okay, any questions so far on our different segments within a circle? All right, then we're going to practice naming different segments within the circle. So number one, first thing we want to do is name the circle. To name a circle, you use the center point. Okay, so we're going to use the center point to name our circle. So I would say this is circle E. Okay, and you do want to use that symbol for a circle so we know what you're talking about. If you just wrote E, E could just be the point. Okay, E is just a point. It's not talking about the circle. Okay, so this is circle E. Number two, we want to name a radius. So again, a radius goes from the center and has an endpoint on the circle. So there are 3 different radii here. Okay, one would be EF. Okay, so one radius would be EF. Another one from the center to a point on the circle would be EH. Okay, then the last one you could have is EG. Okay, so those are the 3 different radii within that circle. Now, you do have problems like this on your assignment. For those ones, you just have to name one of them. Okay, so you don't have to always name all 3. You just have to name one if it's on your assignment. Okay, number 3, we want to name a chord. So again, a chord has endpoints that are on the circle. So what's a name for one of the chords in this circle? JK. What's the other one? HG. Okay, so segment with endpoints that are on the circle. So number 4, we want to then name a diameter. Okay, there is only one diameter in this circle. So that one has to go through the center and have endpoints on the circle. That is HG. Okay, then number 5 says if HG is 8, okay, so H to G, that's the diameter, is 8. We want to find EF. Well, EF is a radius of this circle, and I know that all radii in my circle are going to be congruent to each other. Okay, so to find a radius, I'm given the diameter, and I just have to divide it by 2. So EF would be 4. So again, all radii in one circle are congruent. Okay, so if you find one of the lengths of your radii, all of the lengths are going to be the same. Okay, then looking at number 6, if EG is 10, then HE would have to be what? So if EG is 10, what is HE? 10. Those are both the radius of this circle. All your radii are congruent. Okay, then number 7, FE is 7. Then EG would be, it's very quiet this morning, 7. Okay, those radii, again, are congruent. Any questions on 1 through 7? All right, then we can have congruent circles just like we had congruent triangles and other congruent polygons. Okay, so congruent circles are circles with congruent radii. Okay, so if I have one circle here, say it has a radius of 4 units. Okay, and then another circle radius of 4 units. I could say that those two circles are congruent. Okay, so it has to have that congruent radii for them to be congruent circles. Okay, last chapter we talked about similarity. Okay, so all circles are similar to each other. So it doesn't matter what size the radius is. You have two circles, they're always going to be similar to each other. So if I ever give you a question that says all circles are sometimes, always, or never similar, they're always similar. Okay? Last one here is concentric circles. Those are circles that are coplanar and have the same center. Okay, so with concentric circles, I like to think about a ripple. So if you throw a stone in water, those ripples are concentric circles. They have that same center point, okay? And then it circles out. Okay, those are concentric circles with the same center point. Yeah, I know they're not perfect. Relax. Any questions on the front of our note sheet here? Some of the vocabulary. All right, then if you go to the back, at the very top, what I want you to do for 8, 9, and 10 is draw what it's describing. Okay, so for number 8, draw congruent circles R and H. Number 9, draw 3 concentric circles with center F. And number 10, draw 2 similar circles named T and H. So I want you guys to draw those out for me in your groups.
Go donate blood at 9:15.
9:15?
Yeah.
Okay. All right, first one, number 8. So you should have 2 circles, one with a center of R, the other with a center of H. So don't forget your labels. Now for your radii, you could either use this congruency marker for both. That's fine. Or if you put in a number, say 5, they both should say 5. Okay, so you want to make sure those radii are congruent to each other. Number 9, 3 concentric circles with center F. Okay, so I have a center point F. So I have 1 circle, 2 circles, 3 circles. Okay, so 3 circles with that same center point would be number 9. Okay, then number 10, draw 2 similar circles named T and H. Again, all circles are similar. So you just need 2 circles. Make sure you labeled one T and one H. They could be the same size. If you drew them the same size, that's fine. If you drew one smaller and one larger, that's fine too. Okay, again, all circles are similar to each other. Any questions on those 3 drawings there? All right, so circles can have intersection points, okay, in different ways. So the first way would be 2 points of intersection. Okay, so here I would have my 2 points of intersection. It kind of looks like a Venn diagram, right? So they'd intersect in 2 points that way. You could also have 1 point of intersection. Okay, so you could have 2 circles that intersect at exactly that 1 point that they both share. Or you can have a smaller circle inside of a larger circle where they intersect at that 1 point. I'll get in this later, but that point is called point of tangency. Okay, we're going to talk about that later in section 10.5. Okay, so they intersect at exactly that 1 point. Otherwise, they could also have no points of intersection. So you just have 2 separate circles where they don't intersect at all. Or you could have concentric circles where they share that same center, then they wouldn't intersect at all in any points. Okay, so we're going to use these points of intersection in number 11. So number 11, we're given the diameter of circle S is 30 units. So circle S, that means S is the center point, and C would be part of that diameter, right? So I know my diameter from C to this point over here is 30 units. So what is 1 radius of this circle? What's that length from C to S? Heard somebody say it's 15. Okay, so I found the radius of the circle from point C to point S. I'm also given the diameter of circle R. So circle R is right here. That's your center point. The diameter is 20 units. So from D, and if I had a line here connecting to the other side, would be 20 units. So what's the length from R to D? It's 10. Okay, so your radius for that circle is 10. And you're also given D to S, so that's this length, is 9. And we want to find the length from C to D. Okay, C to D is this piece right here. So we want to find that length. Well, I know from C to S is 15, and from D to S is 9. So how do I find that remaining piece? Subtraction. 15 minus 9. That would be 6 units. So that highlighted part there would be 6 units. Now what if I said I want you to find the length from R to C then? If C to D is 6, right? What's the length from R to C? Four, right? Okay, so from R to C would be 4 because that whole length is 10. Okay, and you do have some problems on your assignment that are like that. So you want to use those diameters to find the radii and then find those pieces in between using that information. Any questions on number 11? All right, then we're going to move into circumference. Okay, circumference plays a big role in circles. Okay, so the circumference of a circle is pi times diameter, or 2 pi times the radius. Okay, so D in this equation here is the diameter. So the length of that diameter. And R in this one is the radius. Okay, so both of those equations there give you the circumference of a circle. Now, the circumference of a circle is the distance around the circle. Okay, so this circumference is the distance around a circle. So if I say, how far will this wheel travel one rotation? That's when you would find the distance around that wheel. Okay? That would be the circumference. When you're looking for the distance around the circle. That's circumference. So pi is the ratio of the circumference to the diameter of a circle, if you're wondering where pi comes from. So in number 12, we are going to find the circumference of each circle. However, sometimes I will ask for exact answers, and sometimes I will ask for estimated answers. So if I say, write the exact answer, that will have pi in it. So you'll leave that symbol pi in your answer. If you're estimating, you're actually going to multiply by pi and get a decimal. It is next week. Okay, so your estimate will have a decimal instead of pi. So number 12, we want to find the circumference of the circle, letter A, with a radius of 5 centimeters. So since I'm given the radius, I'm going to use 2 pi r to find my circumference. Okay, so the circumference is equal to 2 pi r. Given the radius, plug in 5 for r. So we have 2 pi times 5. Now if I said, give me the exact answer, you would write 10 pi and that's it. Okay, so you just write it as 10 pi. That would be your exact answer. If I said find the estimate, you're actually going to multiply by pi. And if you have a scientific calculator, you have a pi button on there. Okay, so you could just type in 10, and then your pi button is right here. So you type pi, and then equals, and you would get your decimal answer to that. Okay, so this would be about 31.4, and our radius was in centimeters, so this one should be in centimeters as well for our circumference. Okay, then in letter B, now we're given a diameter. Okay, since I'm given a diameter, I can use pi times diameter. If you don't remember that one, you can still use 2 pi r. You'll just have to divide by 2 to get the radius. So you'd plug in 4 for r instead. But I'm going to use pi times the diameter. So I'll plug in 8 for D. So again, my exact answer here would be 8 pi. If I was looking for the exact answer. Otherwise, I can type it into my calculator and get a decimal. And I got 25.13 meters. Okay, any questions on how to find the circumference using that formula? All right, then in number 13, this time you're given the circumference, okay? And it's asking you to find what the radius is and what the diameter is. So I'm still just going to use circumference is equal to 2 pi r, okay? So if the circumference of a circle is 106.4 millimeters, we want to find the radius, okay? So that means I'm going to plug in my circumference for C. Okay, because that is the circumference. Okay, C is the circumference. So I'd say 106.4 is equal to 2 pi times r. And what I want to do is solve for r, since that's the radius. Okay, so I'm going to divide by 2. So I have 106.4 divided by 2 is 53.2. That's still equal to pi times r. Now, pi is just a number. Okay, so you can divide by pi to get r by itself. So I'm going to divide both sides by pi. So divide by pi to get r is equal to 16.9. Now you do have to be careful with this in your calculator. You can divide by 2 pi right away. You can do that. But you have to be careful because sometimes it'll just divide 106.4 by 2 and then it'll multiply it by pi on your calculator instead of dividing it by pi. Okay, so put the 2 pi in parentheses then. Your radius should never be bigger than your circumference. If you get a radius that is bigger than 106.4, something's off there. Okay, your radius should not be bigger than your circumference. So now I have my radius is 16.9 millimeters. If I have my radius, how should I find my diameter then of this same circle? Multiply it by 2. So I'll just take 16.9, multiply it by 2. Make sure that's right, because I kept it in the zip form. Yeah. Okay, so it is 33.8 millimeters. Okay, questions on how to find a radius or diameter when you're given that circumference? All right, then last part here. We have a polygon is inscribed in a circle if all vertices lie on the circle. Okay, so we've dealt with inscribed triangles before. Those were triangles inside of a circle. Okay, inscribed means inside the circle. So all your vertices are on that circle. And then a circle is circumscribed about a polygon if it contains all the vertices of that polygon. Okay, so the circle around the outside is the circumscribed circle. So numbers 14 and 15. 14, quadrilateral LMNP. So we're talking about this quadrilateral is blank to circle K. Is that inscribed or circumscribed? If it's talking about the quadrilateral. It's inscribed. Okay, since that quadrilateral is inside that circle and its vertices lie on the circle. Okay, then circle K would be what around quadrilateral LMNP? That would be circumscribed. And again, we did deal with those vocabulary words in Chapter 5. Chapter 5? Yes. Okay, any questions?